Welcome to Electronics Techie. So in this video we are going to discuss about up down counter. So in this video we are going to discuss about up down counter. So in previous videos we have already discussed about up counter and down counter, whereas in this video we are going to discuss about up down counter, means which counts up, which acts like up counter as well as the down counter also. Before that design we are going to know about the up counter design and down counter design. We already discussed about the up counter design and down counter design. If you don't watch the previous video, then go through those videos, then it is easy to understand these two parts. So now you are going to up down counter design. So before that, this is the up counter design we already discussed, and down counter design, this is also you already discussed in the previous video. So this is the up down counter. So how we are going to design means, so first we have to write flip-flop module. So why are going to write means, so for every counter we have to concatenate the flip-flops. So if you want 4-bit counter, you are going to connect the 4 flip-flops. If you are going to design the 8-bit counter, we have to connect the 8 flip-flops. We have to concatenate 8 flip-flops in order. So concatenation means a series of flip-flop is a series of connection is known as concatenation. So here what we are going to do means, so first we have to write the flip-flop module. So here in this design I use T flip-flop, so that's why, sorry, this is the output, so Q. So here I use T flip-flop, that's why I write the code for T flip-flop. So what is the T flip-flop design? So input clock reset and the input value is T. Here the input is T and the output is Q. I already discussed about the T flip-flop design in T flip-flop code and up counter and down counter everywhere, but once again I have to repeat these all. So always at the rate. So when you are going to use this always block, you have to represent output with reg data type. So if you don't mention reg data type, it default will take y data type. But while you are going to use always, you have to store that value in particular register. So that's why you are using this reg. Means for every passage of clock, we have to know the previous value. Why you are going to know previous value? Because the output is going to depend upon the previous value. So that's why you have to make output as reg. So always depend on the passage of clock and passage of reset. So begin. So if reset. So if the reset value is equal to 1. So what will happen? Your flip-flop is going to be reset. Means if you are going to restart your phone. So what will happen? It starts from beginning. Same like as, so when your flip-flops is going to be reset, then it will start from initial state. What is your initial state? 0. So it will assign output as 0. Else. So if the reset value is equal to not 1, it is equal to 0. So in Verilog or any digital circuit, we have only two values, 1 or 0. So if the reset value is not equal to 1 means it equal to 0 only. So none other than other value. So only two numbers in the binary language, 1 and 0. So if the reset value is equal to 0, so then the Q will be depend upon the T value. So what is the T value? According to that, the Q value is going to be assigned. So see here, if the T value is equal to 1, so what is the output? So what is the previous output? Is going to be toggle. Means if here in the previous value Q is equal to 1. Now if the T is equal to 1 means, so your Q value is going to be toggle of Q. So means toggle of 1, that is equal to 0. Like that it is going to be happen. Else Q is equal to Q only. So if T is equal to not equal to 1 means it equal to 0. Then Q equal to 1 only. So if T is equal to 1, it will be make it as 0. Otherwise it equal to 1 like that. I take simple example here. So no need to bother about this. So this is our T flip-flop design code. So now we have to write our main code. So what is our main code? So module up down counter. So input clock reset and up underscore down. So what is the use of up underscore down? So it represent that. So if up underscore down is equal to 1 means it represent, it acts like up counter. So if up underscore down is equal to 1, then it acts like a up counter. So if up underscore down is equal to 0, then it acts like a down counter. So according to this thing, it decides that flip-flop, this counter is going to be up counter or down counter by using this pin. So this is the main one. You have to divide that it is up counter or down counter. So next one is output or count. You have to know the count value. So here the internal connections I use 4 wires. So we have to connect these 4 wires internally. So I are going to connect. So assign T is equal to 1. So everywhere you all know about that. So we have to know in up counter we have to connect T is equal to 1. T naught is equal to 1 itself, because the last one is always going to be toggle in the truth table. So see here, in up counter design or down counter design. So everything 0 to 1, 0 to 1, 0 to 1 to 0, 1 to 0, again like that. In everywhere 1 0 to 1, 1 to 0, everywhere the first output is going to be toggle only. When it is going to be toggle, whenever the input is equal to 1 only, then only it will be toggle for particular time period. So that's why simply write 1 here. So if T1, so what is your T1? So in up counter you have to simply write Q0, and down counter you are going to write invert of Q0. So now you have to differentiate. If that up underscore down value is equal to 1, so these values going to be same. So if up underscore down value is equal to 0, so then this value is going to be same. So now what you are going to write? You have to write the condition. So that's why you have to use ternary operator, conditional operator. So what is this usage? I already discussed in main data types are operators. I discussed this topic in operators. If you don't watch those operators video, you are going to go through that, then it is easy to understand. So simply I will explain here. So if what is the up underscore down, I write here question mark. So these indicates that if the value of up underscore down is equal to true, so true means 1. So if it is equal to 1, then count of 0 is going to be assigned to the output. So means these values going to be assigned to the particular thing. Else, so it is like if condition, means if it is equal to 1, this will going to be your output. So else, this is to represent it will else. So if the up counter is not equal to 1, then what will happen? It is equal to 0. So if it is equal to 0, then what is your output? Invert of count of 0. So here we can simply use, if up underscore down is equal to direct q of 0. Q of 0 is nothing but count of 0 I represent in up down counter. So here invert of Q0. Invert of Q0 is nothing but invert of count of 0. So if the up is equal to 1, your count of 0 be the, it acts like a up counter. If the up down is equal to 0, it acts like a down counter. So simply write in this those two counters in a single line. So how you are going to write means see here. So simply write count of 0 is to invert of count of 0. So this is the T1. So coming to the T2. So T2 here also same thing. So again go to the up counter. See here what I write, q of 0. So you simply make q is equal to count here. So I use q in the up counter and down counter, but count I use count in up down counter. So it is a little bit confusion. So no need to confuse about this. Here I represent output as q, but in main our design you have to use count. So here what it write, count of 0 and count of 1. So here not of count of 0 and not of count of 1. We simply write same here. So if it is equal to true, what is up down is equal to true. So then what will happen? Your count of 0 and operated with count of 1 and count of 0 and operated with count of 1. Else and not of count of 0 and not of count of 1. Simply make here I use count here. So in up counter and down counter I use q. So that is the difference only. So you have to write like same like this. All what you are write in the up counter, you can simply write in the up down counter also. So because of both functionality of up counter and down counter, you simply use this ternary operator in this design code. So this is our T flip-flop. We are going to instantiate the module in the main module. So how we are going to instantiate means you have to write the module name of the what you are going to include. So I am going to include this T flip-flop module. So that's why I have to write that module name as it is, and you have to write the instance name. So followed by port list. So how we are going to connect? So this clock is going to be connected to this clock. So this reset is going to be connected to this particular reset. So these t value is going to be connected to this T0, T1, T2, T3. So this is the, we are going to connect for every flip flop. We are going to connect these four things, and this q value is going to be connected to this count value. So no need to confuse about q and count. So both are same. Where means both are outputs. In up here in up counter I use q. In here in up down counter I use count. So I am saying about this q and count. So not about this t flip flop q. So this is our test. Sorry. So like that we are going to connect these four. What is the four flip-flops we are going to use? This is the 4-bit up down counter. So that's why I simply connect 4 T flip-flops in order like this. We are going to collect the outputs, count of 0, count of 1, like that, and we are going to collect those values. So followed by end module. So this is our test bench code. So we are going to write module followed by module name. So this is our module name. And what is our inputs? We make it as a range data type. So what are the outputs? We make it as a wide data type. So have to write the we are going to instance the design code with test bench code. So here every time I said that everyone get down. So for which module I am going to write the test bench. So always remember that if there is 100 modules, if there is 200 modules, at last there is one main module. So every code there is a purpose of one design only, not a multiple designs. So we are going to use 100 designs. For what purpose? To design a main code. So now what you are going to do means you have to write that particular main module. You have to going to write the test bench code for that particular main module only. So what is our main module here? There is two modules here. So but main module is our up down counter. So TP flub is just for internal connections of your main module. So that's why you have to write the up down counter test bench code here. So up down counter followed by UUT instance name. So here we are going to connect the port connections, clock off, clock reset off, reset means these what are the reset, clock, up down count, these are going to connect with this clock, reset, up down count. We are going to connect with test bench. So here this is our design code. So these are our inputs and this is our output. So this is our test bench. So we are giving inputs and outputs here. So we are by using these port connections, what will happen means these will connect like this. So we are going to connect like this. So this clock represent this clock. So what is so like that clock will connected to clock, reset will connected to reset, up down count reset, up down count, up down is connected to up down, like that. Count will connect to count. So by using these port connections, we are going to connect this design code with test bench code ports. That's why we name it as a port connection. So now we are going to give the values for the inputs. So always a slash flag, these represent that always means for every 5 nanoseconds of time. Here we represent slash 5, it means 5 nanoseconds. For every 5 nanoseconds of time, 5, 10, 15, 20 like that. For every 5 nanoseconds of time, it is going to be toggle. Initially it will take it as 0. So here initial begin we make it as 0. So after 5 nanoseconds it is going to be 1. For again after 5 nanoseconds it is going to be 0. So 1, 0 like that, it is going to be toggle for every 5 nanoseconds. If you make slash 10 means for every 10 nanoseconds. Slash 15 for every 15 nanoseconds, like that it will define here. So here I give clock equal to 0. Always remember that in test bench we are going to give values to the inputs only and verify the outputs in the waveform and any display. So reset equal to 1. Initial I make reset equal to 1 means, so it is all going to be reset, so your Q will be going to be 0. So then your up underscore down is equal to 1. So after 10 nanoseconds of delay, so what will I am going to do? Reset is going to be 0. So then what will happen after reset equal to 0? So if the reset equal to 0, your T will going to be control the Q values. So after the, 160 nanoseconds, I will give up underscore down equal to 0. Means here I make it as a up counter. So for after 160 nanoseconds, I make it as a down counter. So just remember that. So after 160 nanoseconds is not the correct one. 10 plus 160. So 170 nanoseconds. After 170 nanoseconds, I am going to make it as a down counter. So after 80 nanoseconds of this particular 170 nanoseconds, I stop the simulation. So finish symbol represent the you have to stop the simulation for particular period of time. So and after these 4 lines are used to generate the waveform in EDA Playground. So if you are going to use this code in any Vivado or other Xilinx app, so no need to use these 4 lines. If you are going to use this code in EDA Playground itself, so mention these 4 lines and try to observe the waveform. It is easy to understand. So followed by end module. So this is our simulation. So first we are going to clock here. So clock will be toggle for every 5 nanoseconds of time. So reset equal to 0. Initially your reset equal to 0. After 10 nanoseconds of delay, it is going to be 0. We all know about that. So up count. So it will be up count means here it will first it will act like a up counter. Second it will act like a down counter. So here at particular these thing it will be act like a up counter. So see here 0, 1, 2, 3. So up counter means it counts like 1, 2, 3 up and so on 15. So down counter means after particular this period it will act like a down counter. See here 15, 14, 13. So it acts like down counter. So this is about the up down counter. So first initially it acts like up counter according to the your input. So first you are giving up down is equal to 1. So that's why it acts like a up counter. So here you are giving up down is equal to 0. That's why it acts like down counter. So this is about the up down counter. Sorry. Thanks for watching. If you have any doubts, you can comment on it, and if you want any particular design code, you also comment on it. I make that video and send that design code also. And thanks for watching, and thanks for keep supporting.